or anything?
No, ma'am, it's good.
It's okay, ma'am.
It's fine.
Okay. Yeah, if anything has to be changed or any modification has to be done in my way of teaching or anything, you can please text me also individually. Okay, my number is there in the group, and I would take it as a positive thing only. Okay, no worries. Only thing we need to learn together. Okay, so there's no point in me handling in my own way because especially this is online. Okay, so we'll move on with today's topic. The topic for today is 8086 microprocessor. Okay, so we are done with 8085. Actually, in theory part of 8085, it's like just introduction to 8085. So I should have only introduced the architecture of 8085. Okay, that was actually the syllabus. Still, since we have lab, I could not only stop with architecture, so I had to go with addressing modes. Then I had to go with instruction sets because you should understand the lab and do it, right? So that is the reason I had to touch upon all that. Now moving on with the next topic is 8086 architecture. Okay, now this is again a very, can you see my screen, ma?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah. So before going into 8086, let me just ask you very, very simple questions about 8085. What is the data bus size of 8085, ma? Please don't disappoint me. Try to answer these questions. What is the data bus size of 8085?
8-bit,
Very good. What is the address bus size of 8085?
16-bit.
16-bit. Fantastic. Thank you. So here, depending on the address bus, the memory capacity would be decided. I told you, right, in the previous class itself, your address bus size only determines the size of memory. So if you have a 16-bit address bus, your total memory capacity would be 2 power 16. Okay, because see, depending on the number of addresses, you can have number of locations. Number of locations is nothing but the size of the memory. Okay, so if you have 16-bit address bus, 2 power 16 locations you can have. So that is the total memory capacity of 8085. Now, why I'm asking these questions is I want you to comparatively learn 8086 along with 8085. Okay, because you will, when you compare and learn, you tend to remember both in a better way. So coming to 8086 is the next evolution in microprocessor by the same company Intel. Okay, that was in 1976 and this is in 1978. Just a 2 years gap, they introduced or launched another microprocessor, which is 8086. The similarity between 8085 and 8086, both works in 5-volt power supply. Minimum power supply of 5 volt is needed for the chip to switch on. Both has a 40-pin package. Okay, there also there are 40 pins. Here also you have 8086 also you have 40 pins. Okay, there are various other versions of 8086 which is also called as 8088, 8186, 286, 386, 486 and so on. Okay, and that was 8085 was an 8-bit microprocessor, but this is said to be a 16-bit microprocessor. So when I use the word 16-bit, what all would be 16-bit is, number one, your data bus will be 16-bit in size. Okay, your data bus will be 16-bit in size. So when your data bus is 16-bit in size, you can see, you can tell that it's a 16-bit microprocessor. Are you getting it? So 8085, 1 minute, ma. Stephen, I'm in class. Can I call you back? See, when you have a 8-bit data bus, you call it as an 8-bit microprocessor, isn't it? So here, since this is a 16-bit microprocessor, by default, your data bus size will be what, ma? What will be the data bus size? Somebody is trying to enter in. They are late. Their name is not. Yeah, are you able to listen to what I'm saying?
Yes, ma'am.
So what is the data bus size of 8086?
16.
Yeah, the processor size is equal to data bus size, ma. Just remember that. Whatever, if I say 32-bit processor, your data bus is going to be 32-bit. If I say 8-bit processor, your data bus is going to be 8-bit. Okay, so they are both directly linked. Why? Because when I say 8-bit processor, the meaning is my processor will be able to handle 8-bit data. That is the meaning. Okay, handle 8-bit data means transfer 8-bit data. process 8-bit data, store 8-bit data, manipulate 8-bit data. Okay, so anything can be done, only maximum size is 8-bit data. That's why it's called a 8-bit microprocessor. So when I call a processor as a 16-bit microprocessor, what happens is I'm able to do all these processing with the 16-bit data. So naturally, my data bus size should be what? 16-bit. Okay. Now coming to the address bus size, there it was 16-bit. In 8085, the address bus size was 16-bit. Here it is 20-bit. Are you able to get what I'm saying? So can you tell me what would be the memory capacity if the address bus is 20-bit? Come on. Hello, Ma? It's not such a big question. Are you able to hear me?
Yes, ma'am.
So if the address bus is 20-bit, what will be the memory capacity is my question.
2 to the power 20.
Yeah. Why should you think so much for that? You're right. 2 power 20. Okay, 2 to the power 20. So 2 to the power 20 is equal to 1 megabyte is the memory capacity of 8086. Okay, there it was 2 power 16 because we had 16 address lines, and here it is 2 to the power 20 because we have 20 address lines. That is the difference. Okay, and yeah, here we have 64 IO ports. Okay, 64. It can support around 64 IO ports. Okay, so now let's go into the details of 8086. So this is how an 8086 chip will look like. This is the external appearance of Intel 8086. You can see the name written on top of it. And this is the internal microscopic look of the chip. Okay, and this is how it would be embedded. The main processor would be embedded on the chip. Okay, and these are the 40 pins, 20 on one side and 20 on the other side. So you have 20 pins on one side and 20 pins on the other side. Okay, and when you come into the 8086, please stop me if you want me to explain anything once again. Okay. Okay, ma.
Okay, ma'am.
Yeah. So 8086 can be majorly divided into 2 blocks. Okay, when you have the architecture, the whole architecture can be divided into 2 blocks. So see, suppose this is your 8086, I can divide it into 2 blocks. So these 2 pink blocks. One block you can call it as bus interface unit. Okay, and the second block is called the execution unit. So bus interface unit, in short, it's called BIU, the full form of bus interface unit. And EU means execution unit. Okay, ma? So your entire architecture itself can be divided into these 2 blocks. Now, can you tell me what are the phases of executing an instruction? When I have to execute one single instruction, what are the different phases that instruction has to go through? I've told this many times. First is
Fetch,
very good. Then
decode, and execute.
Then
Execute.
execute, and the last maybe write back. Right, writing the result or storing the result back wherever it is needed. Now, since your 8086 architecture is divided into 2 units, the first unit, which is BIU, is meant for fetching the instruction. So what happens within BIU is fetching of instruction from the main memory. Main memory will not be on the CPU, it will be somewhere outside. So you'll have to go to that and fetch the instruction and bring it. So that job will be done by your BIU unit. Okay, and as the name itself says, execution unit deals with decoding and execution of the instruction. Okay, so when there is no write back, it means execution itself has got by default those steps. That is why that write back is skipped over here. Okay, so your fetching part will be done by BIU unit of 8086. Decoding and execution part will be done by the execution unit of 8086. Is that clear, ma? Clear?
Yes.
Yeah. Now, the main difference between 8085 and 8086 is 8086 is comparatively faster. Okay. when a job is done by one person, same job done by two people, who would complete it first? First or the second? Right?
Second one.
Second, because two people are doing it. So which means the job is shared. There is some parallel processing happening, right? So the same concept in 8086, there you did not have two separate units. It was all together. Architecture was all together. So only when fetching completes, decoding and execution has to be done. But here, since there are two separate units in the architecture, one unit is only in charge of fetching. So it will go fetch the instruction and bring it. By the time the execution unit will do decoding and execution. By the time when decoding and execution completes, the first will go and fetch the second instruction. Got it? So this will be kind of parallel processing would take place. Okay, so that is what makes 8086 much faster or much speedy compared to 8085. Okay, so suppose first instruction, 8085 will go and see the BIU unit will go and fetch the first instruction. After fetching, it will send it to EU. EU will decode it and execute it. By the time this decodes and executes, this BIU will not remain idle. It will go and fetch the second instruction and keep it ready. I'm getting it. So by the time this completes execution, the second will be readily fetched. So that will be passed on for execution. By the time the third instruction will be fetched. So what happens is here, comparatively, since there are two units, there are parallel processing that takes place, which reduces the time for execution of an instruction. Got it, ma? So that is what is called as the word parallel processing. Okay, parallel processing. Okay, the other single term for it is called as pipelining. This is not there in 8085, but it is introduced in 8086. Today's processors have got a very high level pipelining, but this was the first processor which introduced the concept of pipelining. Have you understood what is pipelining?
Yes, ma'am.
Yeah. Coming to, yes, ma, please. Somebody called me? Is anybody?
No, ma'am.
See, people coming late, they distract us by waiting there and then they start calling me, sending me messages. Please try to be on time. Okay, so here, let's just go through the points one by one. 8086 is divided into two functional units. One is BIU and the next second is EU. So mainly the separation is done because to increase the processing speed of the processor. Okay, I will share the entire presentation with you. So you can go through this also on in your own pace. Okay, now BIU contains the following. What are the following? It has an instruction queue. It's got some registers. It's got an instruction pointer and it's got an address adder. I'll tell you what is all this. Okay, and BIU, what all operation it performs is majorly it does instruction fetching. Okay, first main job for BIU is to fetch instructions from the memory. Second, to read and write data or operand from the memory. Either to read data from the memory or to write data to the memory. Both are done by BIU unit. And third is read and write data from IO device. Okay, that also is done by BIU. And one more important task that BIU does is it will calculate a 20-bit physical address. So this is something new which needs more explanation. As of now, just take it. Maybe in the later part, I will explain to you how this calculation is done. Okay, so what are the tasks of BIU? Number one, fetching an instruction from the memory. Second, can somebody say what is the second operation?
Writing.
Reading or writing data from?
Operands.
Pardon? From?
Operands to memory.
Reading or writing operands from memory or to memory. Third is reading or writing data from? Data and operand means the same. Data from? One is memory. What's the other one?
IO device.
Very good. From the IO device. And the last but important task is to calculate the 20-bit physical address. Okay. So these are all the tasks of BIU. Now, BIU has got something called a queue. What is a queue? It's a type of data structure. What is the principle of operation of queue, ma? We saw about stack. Now, what is this queue? It works on what principle?
Ma'am,
What-
FIFO.
Pardon?
FIFO.
FIFO, yeah, it's given here. What is FIFO? Can you elaborate it?
First, like something we are adding, like it is the first, and the elaboration is first in, the first out.
Very
So
good.
whatever we are adding in the first one, the first will go out.
Okay. The first element will come out first, right? First in, first out. So, or whoever goes in first will be coming out first, right?
Yes,
Just,
ma'am.
just the opposite of stack. So now here, there is a queue. See, one of the example is your ticket counter has got a queue system. Okay, right? So whoever comes first to purchase the ticket would be given the first chance to get the ticket. So that is the process of queue. So here you have a very small size queue, not a big queue, just a 6 size queue. Okay, up to 6 instructions you can pre-fetch and put them together in that instruction queue. Okay, so what happens is you need not wait for the execution unit to execute all the instructions. You can go pre-fetch the instructions from the memory and put them in a queue. Keep them waiting. One by one, it will be taken by the execution unit. It will be decoded and executed. Okay, so what happens is you need not wait for the instruction to be executed and then pre-fetch. Already you can fetch it. Up to 6 instructions you can fetch and load it into the instruction queue. Got it, ma? So for that purpose, you have a small queue data structure that helps in pre-fetching. Please note the word, it's called pre-fetching, which means it is fetched even before it is needed. That's why pre-fetch. Okay, ma? Yeah. So that is available in your BIU unit. As I told you, BIU unit, the major task is fetching instructions. Okay. Fetching it even before it is needed is your saving time. So that is what happens in B. I'll show you the diagram of what a BIU unit consists of in the next slide. Now coming to EU, EU has got control unit. It's got an instruction decoder because it has to decode the instructions. Control unit, why means because it has to generate control signals for carrying out the instructions. Then it has an ALU to execute the instruction. Then it has some registers. And of course, whenever you have ALU, you'll be having some flag registers or condition code registers. Okay, so all that is available in the EU because EU takes care of decoding.